Good morning, guys. Today we're going to start chapter 9, and we're going to talk about something called polar coordinates. Now, you are familiar with what are called rectangular coordinates. Okay, if you have a point somewhere, you can always get to that point with two pieces of information. You need to know how much do I travel in the x direction, how much do I travel in the y direction, and then I'll land on that point. Today we're going to talk about another way to find the point, and I apologize, but here at the beginning I'm just going to have to kind of read the notes and just better explain what's going on. I don't like to read to you guys, but that's what's going to happen. So in a rectangular coordinate system, a point in the plane is represented by ordered pairs. Okay, you got x, y coordinates, where x and y are like a certain distance from the origin. You start at the origin, you go a certain x, a certain y. Well, for what's called a polar coordinate system, we're still going to have a starting point. Now that starting point is called the pole, and you're going to think of that like the origin. Okay, so that's our origin. You'll notice if you glance down at the bottom, our graph looks a little bit different. Okay, this is a polar coordinate system instead of a rectangular coordinate system where everything is in squares and vertical and horizontal lines. This is going to have some circles here. Okay, so this is what our graph's going to look like. So that's going to be the pole, but you can think of that as the origin. Okay, you've got a pole, and then this is your starting point. This is your polar axis, and this would be like, this is like 0. Okay, so 0 degrees or 0 radians. We're actually going to be working a lot with radians again. So that'd be like 0 radians. So this is your starting point, and this is your starting position, like you're looking this way. Now, a point P in a polar coordinate system is represented by a set of ordered pairs. Okay, instead of an x and a y, you have an r and a theta. R, if r is greater than 0, if it's positive, r can actually be negative. Both of these can be negative, just like x and y coordinates can be negative. Okay, r greater than 0, r is the distance of the point from the pole. So from the pole, you're going to go out a certain distance. Theta is the angle formed by the polar axis and a ray from the pole through the point. Now, let me explain this. This is how it's going to be given to you, r theta. When I do these, I look at the theta first. Because what this means is, I have a point somewhere. What direction is it? Okay, that's what theta is. Okay, is it 30 degrees? Is it 45 degrees? Okay, point to the point. And then r is how far out it is. So point to the point, and then you're going to walk out in that direction a certain amount, and that's your r. So your theta is your angle, and then once you got your angle, you know which way you're headed, you just start heading that way. And you'll just go 1, 2, 3, 4, however many you need to get to that point. So when I look at this point, r theta, when I graph them, which we're going to do in a second, I actually do them backwards. I find the angle first, and then I just take that many steps out towards that angle. Okay? Or, now what this says, like I just said, r and theta, either one of these, they could both be positive, they could both be negative, you could have one of each. Now, a negative theta just means you rotate. Remember, positive angles we rotate in a counterclockwise manner, negative we rotate in a clockwise manner. So that's what a negative angle means. A negative r means you go backwards. So if this was my angle, so here's theta, and my r was negative, then instead of going, so what is this? Let's say this is 60 degrees. So I look 60 degrees, it's probably more than 60 degrees, but then instead of walking towards that 60, I walk backwards. Okay, think of it that way. That's what a negative r does. Okay, so let's plot some points. You're going to see this is actually pretty easy. Okay, the hardest part is going to be finding these points here. So remember, this is pi over 2. This right here, this would be pi over 4. This would be pi over 6. So that's like 30 degrees. And this is pi over 3. So this one, this would be like pi over 12. or 15 degrees. We're not going to use that one a whole lot. Same with this one here. So the very first line you see and the very last one, you're not going to, this is like 75 degrees. Okay, we're not going to use those a whole lot. Okay, so these are your biggies. 0, pi over 6, pi over 4, pi over 3, and pi over 2. Okay, and then going around the circle. So plot the point. 2 and then 3 pi over 4. So again, I find theta first. 3 pi over 4. Well, here's pi over 4. 3 pi over 4 is over here. This is 3 pi over 4. And then we're going to take 2 steps in that direction. Well, that's what these circles are. Okay? That R stands for radius. Well, I have all these circles, and this would be 1 radius, and this would be 2 radii. Sorry. So it's right here. That is, I'm going to call that point A, since I got an A there. Okay, so that's point A. B, 4 comma negative 2 pi over 3. So first off, let's figure out where negative 2 pi over 3 is. Here's pi over 3. So this, going this way, this would be negative pi over 3. So it was 1, 2, 3, 4 of these lines. So now I'm going to go another 1, 2, 3, 4, and that'd be negative 2 pi over 3. So there's my angle, and I need to take 4 steps in that direction. I'm sorry, I think of it like a pirate. Okay, you're facing a certain direction, and then you're like taking that many steps to figure out where the buried treasure is. I don't know, whatever. Sorry. All right, so and then 1, 2, 3, 4. So that would be B. Okay. Now here's the weird thing about these. That exact same point could be written in like 3 other ways. Okay, there's a lot of ways you could get to this point. I could have said B was, look at pi over 3, and then go backwards 4. So negative 4 pi over 3. That would have been the exact same location. Okay, I could have said, instead of negative 2 pi over 3, what's that exact same angle written in a positive direction? Well, this is 1/3, 2/3, 3/3, that'd be 4/3. So I could have called that point 4 pi over 3, that's the angle, and then still gone out positive 4 in that direction. Okay, so they're kind of unique that way, where I can talk about the same point in like 4 different ways, depending on telling you which way to face and whether you walk forwards, whether you walk backwards. Okay, so take a look at C and D. I'm going to pause this, see if you can plot those 2 points, and then press play and see if you're right. All right, so C was 5, 0, so 0 radians, so we're on what's called the polar axis, and we're just going to take 5 steps in that direction. So there's C, and then D, the angle was pi over 3, so there's pi over 3, but it was negative 3 was my radius. So I was like looking at this angle, but then I walked backwards. 1, 2, 3 steps, and that's where D was. Now, on the back, take a look up here. Look at point P. Now, any point in the world, anywhere, can be found using rectangular coordinates, like you've always done. So go over a certain x, go up a certain y. But they can also be found using these polar coordinates. So look at a certain angle theta, and then go a certain distance r out towards that point. Okay? 2 different ways to do it, we still land on the same point. Well, that means that we can convert between the two ways of writing these coordinates. Okay, we can go from rectangular to polar and from polar to rectangular. So first we're going to look at going from polar to rectangular. So what I'm saying is I'm going to be given an r and a theta, and I want to convert that into an x coordinate, and then I want to convert it into a y coordinate. So one at a time, take a look at what's going on. You're going to have r and theta, and I want to turn that into an x. Well, if you look at this as a right triangle, this is the side that is adjacent to our angle. This is the side that is the hypotenuse of our angle. So if you set that up as, so think of this, what is this? This is the adjacent, and that's the hypotenuse. So the cosine of our angle equals x over r. Okay? Well, if I want to solve that for x, I just have to move the r up. So x is equal to r times the cosine of theta. That's it. And so what would y be? Well, y is the opposite side. So this would set us up into like a sine situation. We've got the opposite. Well, we're wanting to find the opposite. We're going to have the hypotenuse. We're going to have this angle. So y is equal to r sine of theta. And that's it. So for these next two examples, I'm going to convert this r theta into x's and y's. Now, I am going to use my chart so I get nice perfect values, no decimals, because some of these would be like weird decimals if you took the sign of them or whatever. Okay? So, like for example on this one, x is equal to r times the cosine of theta, pi over 4, and y is equal to 5 times the sine of theta, which is pi over 4. All right, so x is 5 times, what's the cosine of pi over 4? Pi over 4, that's radical 2 over 2. Now, this doesn't simplify a whole lot. 5 times radical 2 over 2 is just 5 radical 2 over 2. That's my x coordinate. Now I'm going to do the same thing over here. Well, again, the sine of pi over 4 is also radical 2 over 2. So 5 radical 2 over 2. Okay, and that's it. Now, that looks a little weird because we've got fractions and radicals and everything. If we wanted decimal approximations, we could do that. We could put it in our calculator. But for these, I want nice exact values, so just do it like that. Okay, so why don't you try B? Pay attention to the R that I gave you, and also pay attention to the angle. Okay, think about where that is, 5 pi over 6. What quadrant is that in? And make sure when you take either the cosine or the sine of that angle, you do so correctly. Okay, I'm going to pause the video. I would ask you to do the same. All right, so here's my point. Radical 3, negative 1. So if you got that, great. If not, take a look at my work and see where you went wrong. Okay, so x, negative 2, cosine of 5 pi over 6. Well, 5 pi over 6 is in quadrant 2. So when I take the cosine of 5 pi over 6, from my chart, I'm going to get radical 3 over 2, but I know it's going to be negative radical 3 over 2. So those two negatives are going to cancel each other out. The 2 in the numerator and the 2 in the denominator are going to cancel each other out, and it just left me with the radical 3. Whereas over here, the sine of this angle is positive, so there isn't a negative to cancel out the negative. That's why I have a negative in my answer, but the two 2's do cancel each other out. Okay? All right. So that's going from polar to rectangular, and then you can go in the opposite direction as well. Okay? So, again, take a look at this picture. So here's my x and here's my y. So that's what we're going to be given this time. So I'm going to have x and y. The first thing we're going to do is we're going to find r. Well, r is the hypotenuse of this little right triangle that we've got. So if we've got x and y, it's just going to be the Pythagorean theorem. X squared plus y squared equals r squared. So r would be the square root of x squared plus y squared. Technically, it would normally be the positive or negative, but we're just going to stick with the positive version. We could have negative, you could have negative, but then it changes what you got to do with your angle. So trust me, we're going to stay with the positive version when it comes to our r's. If we need a negative, it's going to show up in the next step. Okay? Now, theta. What's theta in regards to x and y? Well, here's my angle. Y is the opposite side. X is the adjacent side. So the sides that we're given are going to be a tangent situation. So the tangent of theta is y over x. Or theta would be the inverse tangent of y over x. Okay? Now, here's where we're going to run into a little bit of a situation. Okay? So, take a look at this example right here. Now, there are two there's two different angles. Remember, when we do this inverse tangent, when you see this symbol, we're only talking about these two quadrants. Okay, these are the principal values. So the inverse tangent of a positive is going to give us an angle in quadrant 1, and the inverse tangent of a negative is going to give us an angle in quadrant 4. But we could have an angle that's over here in quadrant 3, or we could have an angle that's in quadrant 2 where tangent's negative. So how do we know which one to choose? Okay, when we take the inverse tangent of this, should we have this angle or this angle? Okay, when we do the inverse tangent, should it be this angle or this angle? Well, think about it. If we're over here in the non-principal area, we got there by moving left and then going up or down. Whereas if we're over here, we've gone right and then we went up or down. Okay, so remember, we are given an xy coordinate. If the x is positive, so if x is greater than 0, positive, then that's it. We're over here. We're one of these. If this is a positive, we're going to have an angle in quadrant 1. If it's negative, we're going to have an angle in quadrant 4. If x is negative, so I'm over here, then we're going to do the exact same thing. We're going to take the inverse tangent of y over x, and then we're going to add pi to that answer. So I'm going to get like an angle over here in quadrant 1, but I'm actually not supposed to be in quadrant 1. I'm going to add pi, and that's going to move it over here to where I actually want to be. Okay, so we'll do a couple examples of this, and you'll see what's going to happen. Now, we only do this when the x that's given to us is negative, less than 0. Okay, so take a look at the first example. First example, so this is an xy coordinate. So x, y. So first off, the r that we're going to find is just going to be the square root of x squared plus y squared. Well, that's going to be the square root of negative 6 squared plus 0 squared. Well, negative 6 squared is 36. The square root of 36 is 6. That's it. That's our r. Our theta is going to be the inverse tangent of 0 over negative 6. 0 over negative 6. But since our x is negative, which means we want to be over here somewhere, we're going to add pi to that answer. So, first off, 0 over negative 6 is 0. So that's what we're doing. We are doing the inverse tangent of 0, and then we're going to add pi to that afterwards. So, let me grab my chart. The inverse tangent of 0 is 0. Okay, so here's 0. We're going to go up, and we're going to get an angle of 0. Okay, so the tangent of 0 is 0, but the inverse tangent of 0 is that 0. Okay, so this is 0, but I need to add pi to that. So that's what my angle is going to be, pi. So put these together. This is not an answer. This is just my work. My answer is the point 6 comma pi. So let's think about that. Let's visualize this. Look at pi. There's pi. And then take 6 steps in that direction. 1, 2, 3, 4, 5, 6. There's that point. Well, look at the point that they gave us. In xy coordinates, it was negative 6, 0. So go 6 to the left. Do not go up or down. Same point. Okay? So, if the x is negative, we have to add pi, and that gets our angle going in the right direction. Okay? Look at the next one. Negative 3, 3. So again, r square root negative 3 squared plus, and then just 3 squared. Alright, so negative 3 squared is 9. That's another 9. So this is the square root of 18. Do not put that in your calculator. Just simplify it. 18 is 9 times 2. 9 is a perfect square. So I can pull that out. 3. I can leave the 2 under the radical. So that's my r value. 3 radical 2. Nice and exact. Okay, no calculators. Don't touch a calculator. Next class, you're going to be able to use your calculator on some things, okay, but not for this. Theta is going to be the inverse tangent of y over x, so 3 over negative 3. And again, since my x is negative, I'm going to add pi to that. All right, so this is the inverse tangent of negative 1 plus pi. Okay, so look at my chart. Inverse tangent of 1 is pi over 4. That's the angle in quadrant 1 that has that tangent value. The inverse tangent of negative 1 would be negative pi over 4. So that's what this is, negative pi over 4 plus pi. So so think of this as negative 1/4. I'm adding 4/4. I'm adding 1 positive 4/4. So that's going to be 3/4. So that's my angle. So again, put these two together. This is just work. These aren't my answers. My answer is 3 radical 2 and then 3 pi over 4. That is the r theta coordinate that matches that xy coordinate. All right, last one. You try. Try C. I'm going to pause this, and you can press play and then check your answer. All right, so there's my r value. I got 2. Okay, it was my x squared, so radical 3 squared, but that's just 3. My y squared, 1 squared, but that's just 1. 3 and 1 is 4. Took the square root of that and got 2. That's my r value. And then theta. It's the inverse tangent of y over x. And then that's it. It's just y over x. Don't add pi to this one. Okay, our x is positive. It's easy to do that because you just did 2 in a row where you added pi both times. But you have to stop and look at that. A positive x means this should be somewhere over. So think about this. Radical 3 means you go right and then you go up. So you're in quadrant 1. So we want an answer in quadrant 1. So 1 over radical 3 is really radical 3 over 3. I then used my chart, radical 3 over 3. I went up and got pi over 6, and then that's just it. That's my angle. So the point is 2 comma pi over 6. So take a look at your worksheet as far as plotting points, as far as converting xy's into r's and thetas, and r's and thetas into x's and y's.